this lesson, we will learn about the impact of weather events on our risk analysis. So what is weather modeling? Almost every project involves outdoor work and will be subject to some kind of weather conditions that may dictate working and non-working periods for all or part of the workforce. In normal deterministic schedules, we usually account for weather conditions by making an allowance for downtime in the relevant schedule calendars. However, in reality, weather is often more complex and uncertain than this, and requires special probabilistic techniques to be able to model its potential effects correctly. Weather modeling can be broadly divided into three main categories: weather uncertainty, calendar events, and risk windows. Firstly, weather uncertainty. This refers to variations in normal weather conditions. For example, in the month of March, in a specific region, there may be an average of 10 hours of downtime due to inclement weather. However, historical data may show that this could be as little as 5 hours or as much as 30 hours. An impact probability distribution would be required to express that uncertainty. Secondly, we have calendar events. They are similar to risk events and are assigned a probability of existence. Typically, they refer to distinct events such as floods, fires, cyclones, or hurricanes. These are events that may or may not occur, but if they do, they may have a similar impact across large portions of a project plan. Similarly to risk events, calendar events can be assigned minimum, most likely, and maximum duration ranges, and can be applied selectively to tasks within a schedule risk model. There are two distinct ways of defining a calendar event. Firstly, say we want to define a weather event for poor weather. Here we would have 100% probability that results in an uncertain number of lost working days. This downtime would be distributed throughout a period with minimum, likely, and maximum distribution. Secondly, we may want to define a weather event for days lost due to cyclone activity. In this case, we would have a probability of less than 100% that occurs during the cyclone season. Again, the downtime would be distributed throughout the period with minimum, likely, and maximum distribution. Other types of calendar events could also cause downtime, and they would be modeled in the same way as cyclone events. These would have seasonal patterns and include offshore impacts from wind, sea, and swell. Lastly, we have risk windows. They refer to periods within a schedule model in which certain operations can or cannot be undertaken. Unlike weather events, risk windows have a 100% probability of existence. Typical examples of risk windows are the opportunity to move materials in tropical areas due to seasonal flooding, the ability to use waterways for moving goods if they have frozen over during winter, or blockout periods where certain activities cannot take place. Incorporation of weather modeling in schedule risk analyses adds significant benefits over the options for weather allowances in deterministic schedules because of the wide range of outcomes possible and the probabilistic nature of weather uncertainty. So let's have a look at calendar event modeling. We are going to model the effects of potential cyclone events. If it is not already open, select the Acumen icon in the top left and open My Risk workbook from recent workbooks. Once the workbook is opened, click the S3 Risk tab. In the left-hand Projects pane, highlight Initial Plan. Then select the left panel drop-down and choose Risk Register. The Risk Register window will open in its default view. Now we need to decide whether we want to add a calendar event or add a risk window. Let's create a calendar event for cyclones. In the Risk pane, select the pull down for type and choose Calendar Event. Name it Cyclone Example. Note that the fields for probability and impacts become grayed out. Now if you look at the bottom window, you'll note that the radio button for calendar event has automatically been selected and that the lower pane is populated with 12 months of the year. The ID and description fields will be automatically populated, but you can edit them in the lower pane if you need to. Now, I live in the southern hemisphere, so our cyclone risk will be annually from the 1st of November to the 30th of April. So we're going to create a typical cyclone calendar for this region. We can go ahead and start entering the correct cyclone details for our weather calendar. Firstly, in the lower pane, deselect the options for the months May to October. We won't be using those months. Then, starting in November, enter 5% for probability and minimum equals 3, likely equals 3, and max equals 4. For December 2015, enter 10% probability, then minimum 3, likely 3, and max 4. Continue to enter the remaining probabilities and uncertainty distributions for January, February, March, and April, as per the cyclone calendar table on your screen. So you should now have completed entering the data for the calendar event for our cyclone period. At the bottom left of the lower pane, there is a checkbox where you can prevent activities from splitting across the event or window. We will discuss this option a little later in this lesson. Now let's have a look at risk windows. This window is very similar to the weather events window and works in exactly the same way. Let's create a new risk window and we'll call it Blockout. So in the top menu, click on the button for Add Risk Event. A new risk event will appear in the risk pane. Then in the risk pane, select the pull down for Type and choose Risk Window. Name it Blockout. As with calendar events, note that the fields for probability and impacts become grayed out. Now if you look at the bottom window, you'll note that the radio button of our Blockout shows fields for start and finish dates for minimum, most likely, and maximum. Say we had a canal that was likely to be frozen from December to April in any particular year. We could define a blockout period here. So in the bottom of the window, enter 1st of December 2012 for most likely start and the 1st of May 2013 for most likely finish. We'll make the minimum and maximum plus or minus 2 weeks either side of the most likely date. So we'll have minimum start 17th of November 2012, minimum finish 17th of April 2013, then maximum start 15th of December 2012 and maximum finish 15th of May 2013. Directly below the minimum, most likely, and maximum fields, there is an option to prevent activities from splitting across the event or window. Now sometimes an activity may span a non-working period such as a weekend, public holiday, or a specific exclusion date. If you tick this box, the activity that has been assigned to it will be delayed rather than being split. In this case, leave this option unchecked. So we have our first blockout period. If the project runs for more than 1 year, then we need to create blockout periods for each year that is spanned by the risk model. Therefore, for the second blockout period, we would increment our dates by 1 year, and so on. From within Acumen Risk, you cannot copy and paste risk events. However, you could export the risk register as an Excel file and build your risk register from within Microsoft Excel. Then you could re-import the completed risk register back into Acumen Risk. Now we have 2 risks for a calendar event and risk window. All that remains is for us to assign these risks to activities or group headings such as WBS elements. Although we covered risk assignments in an earlier lesson, we'll quickly assign our new risks to activities. Currently, we have the risk register open, so click the drop-down for Right panel and select Activities. Make sure that the initial plan is selected, then minimize the left-hand projects pane to give us more space. In the Activities pane on the right, Set the display level to 4 by clicking Activity View, Grouping, Display Level 4. So our panes are set up so that we can assign a single risk to multiple activities. Select the risk for cyclone example in the left pane. Then in the right pane, scroll down to the Construction WBS element and select the checkbox. Then do the same for the Commissioning WBS element. In the lower pane of the Risk Register window, click the Mappings tab to confirm the mapped activities. Now select the Blockout Risk in the Risk Register pane. Once again, in the right pane, select the checkboxes for the WBS headers for both construction and commissioning. So now we have assigned our 2 weather risk events to activities in our model. So weather events and weather windows would form part of the risk events that form part of our model. Once we have assigned weather calendars to all impacted activities, we can continue with our risk analysis. Click the Acumen icon at the top left and select Close from the drop-down. Make sure that you save the workbook. In the next lesson, we will learn how to create risk-adjusted schedules for export. In this lesson, we will learn how to create risk-adjusted schedules for export. If it is not already open, select the Acumen icon in the top left and open My Risk Workbook from Recent Workbooks. Once the workbook is opened, click the S3 Risk tab. In the left-hand Projects pane, highlight My Risk. Now assume that we have progressed to the stage where our risk model has been analyzed for risk. In earlier lessons, we went through the steps of creating a scenario using the Create Copy option from the Build Scenario pull-down. We then worked through our options for mitigation. Occasionally, we may have a customer where we need to create a schedule that has been recalibrated based on the customer's uncertainty rankings for their project. This will also include risk events. Acumen Risk can automatically create a risk-adjusted schedule for the customer using scenarios for risk inputs or risk outputs. Then once we have created our risk-adjusted schedule, the new schedule can be used as the basis for developing a new risk model. Before we create our scenarios, let's look at the options for the Build Scenario pull-down. Click the pull-down in the top menu and you'll see that we have 3 options. Create Copy. This will create an exact copy of the highlighted scenario or risk model in the left Projects pane. We have already worked through this option. Then we have Risk Inputs, and lastly we have Risk Outputs. Let's have a look at a risk input-based schedule. Here we have the option for creating a scenario based on risk inputs. This will build a new scenario that is based on the risk model uncertainty inputs. If you hover your mouse over this option, you'll note that it has 2 methods for building the new scenario. We have the PERT method. This will build our risk-adjusted schedule scenario using a weighted average of minimum, most likely, and maximum values. So it uses the PERT algorithm to recalibrate the schedule or cost model. Then there is the distribution median. This will build your risk-adjusted schedule scenario using an average value. This method takes the median value between minimum, most likely, and maximum to recalibrate the schedule or cost model. Once we have created our risk-adjusted schedule, it will be displayed in the Projects pane on the left. Now, let's look at the risk output-based schedule. This option allows us to build a risk-adjusted scenario that is based on outputs of our risk analysis. At the bottom of this option, there is a field where we can select the value for our P schedule. Once we have run a risk analysis, from the Build Scenario drop-down, we can select a P value, say P80, and the P80 values for each activity will be calculated. Then we can click on the option for Scenario based on risk outputs to create a deterministic schedule scenario based on CPM methodology and existing logic. Again, our risk-adjusted schedule will be displayed in the Projects pane on the left. To export the risk-adjusted schedule, click the S1 Projects tab. Then in the Projects pane, right-click on the file and from the pull-down, select Export as Oracle Primavera P6 XER. Let's work through an example of creating a risk-adjusted schedule based on risk outputs. Click the S3 Risk tab and make sure that My Risk is highlighted in the left Projects pane. Click the Build Scenario pull-down from the top menu. At the bottom of the window, select P80 for the P-schedule value. Then click the button for Scenario based on risk outputs. You'll see our new P80 scenario in the left Projects pane. Now we'll rename the scenario. In the lower pane of the Activities window, change the description to P80 Schedule. Then click the S1 Projects tab. In the left-hand Projects pane, right-click on the P80 Schedule. Click Export as Oracle P6 XER and a browser window will open. You can now save the XER file to a folder of your choice. I'm not going to do that here, so I'll just click Cancel. Don't save your workbook, so simply close it and click No. In the next lesson, we will go through another recap and work through an exercise to analyze and mitigate our results.